is for educational purposes only. It demonstrates attacks to raise awareness of security vulnerabilities and teach ethical hacking practices. Important. Always use these techniques responsibly and legally, with the explicit permission of the system owner. Unauthorized hacking or malicious use is illegal and punishable by law. Goal: to educate individuals on improving cybersecurity measures by understanding potential attack methods.
We are going to speak about some techniques of session tampering and how we can protect these trials from the attackers through F5 big IP ASM module. The first example that we will start with is something called CSRF, or cross-site request forgery. It's a vulnerability in the web application that enables attacker from taking actions on behalf of the legitimate users. This will happen without being blocked by the server side. For this reason, it's called forgery. This could be seen very much in banking activities. Always you hear about people that had a problem into their account in the bank, money is transferred without even notice that they are transferred to another account, and this what we call cross-site request forgery. So the attacker tampered the session of this user, and then it is responsible for transferring money to another account. Our lab today will focus on a specific action done by the legitimate user from somewhere else rather than the source of the request, and then we'll see that it's a CSRF attack and the ASM module is going to stop this. So the idea here, for example, I have a registration page to start creating a new user, right? What if I need to change the password for this user? So I'll open a page of changing the password, then we can change our password from the legitimate page, right? What if the attacker takes this page as an HTML page and then he opened it into another device or another browser? So by running this HTML code that was taken from the real page on another PC with putting the URL into the action form to completely simulate the real world scenario, if this HTML code run and the password changed successfully, so this means that this web application is vulnerable to CSRF attack, because simply it's like a simulation for the real world attack from the attacker. The attacker is trying to run a special HTML code or a special actions or a special scripts on behalf of the legitimate user. So if it accepted this action from another device or from another browser, this means it's vulnerable to CSRF attack. We are going to see this without ASM module to make sure that our web application is vulnerable to this kind of attack. Then we are going to apply our policy to see the blocking pages for this attack. So again, what's the real world scenario here? Of course, the attacker will not take the form as it is. Okay, so we mentioned that the HTML page code will be taken from the attacker to be run in another place on behalf of the legitimate user, but keep in mind, it will be fool to enter the HTML code as it is. So values need to be entered into this HTML code directly to complete our attack. So for example, here I will not take the whole form with input fields that needs a value. I will put the value myself. So for example, I know the password. This is the new password that I need to enter into the input field. So in value, I will put a specific password, and the type will be hidden, not to be shown by the user. Because if the user detected that there is another page and there is an input field for the password, he could notice that it's a trial of tampering the session of him. So we need to put the value here. So this is a real world scenario again. All the input types will be hidden and values must be entered directly, not to make the user notice that there is something strange here. Finally, we need a way of social engineering to send this link to the user, because the user needs to click on this link to run this HTML code to qualify the action. So we will use kind of social engineering by sending him into a phishing link, through mail, through our website, whatever the method is, but the user needs to click on this link to start running this code right here. So what is the ASM rule to defend against such attacks? Fortunately, ASM is able to detect such tries from the attacker because of its awesome database of attack signatures, as we are going to see in our lab. So the request will be blocked. So if the attacker tried to run cross-site request forgery, the attacker will be classified as you see here because of ASM module. The second type that we will speak about today for session tampering is something called session hijacking. So it's a trial from the attacker to steal your session ID gotten from your cookie by somehow related to the login account. Then he can, by doing this, escalate to all permissions used by this user. So session ID is a part of your cookie. If it's stolen by somehow, the attacker can do anything related to this session ID for a specific user. Suppose it's the admin of the web application. So if this session ID is stolen from the attacker became the admin of this web application, so it can do whatever he wants. ASM can defend against such attacks using a bunch of techniques included together depending on the device ID, polling, so it can differentiate between sources of accessing web application by using this session ID. We are going to see this combination in our lab. So by defining the device ID, ASM can know who is the real user, because the session ID will be stolen from one device to be run on another device. By polling the device ID, ASM can differentiate between the sources of these trials. So how attack happens in our lab? Firstly, the legitimate user will log in. Then we are going to get the session ID from the cookie. We are going to copy it and put it into the other cookie on Kali Linux, like what you see here. So using Burbersuit, I'll put the session ID here, which I got from the previous trials from the legitimate user. Then I will forward the traffic to our web application. Then we are going to see that we will be able to log in successfully using the same user name without entering any password or anything, only using the session ID. So if your web application is vulnerable to these attacks, then simply your web application will permit any other trial to log into this web application using the same session ID. So how to protect against session hijacking? Firstly, we need to enable session hijacking defense inside a session tracking component using device ID. So firstly, we have here a session tracking. We have spoken about this in the previous sections of this course about session tracking. Firstly, we need to enable session hijacking here, but keep in mind, device ID must be enabled on the bot profile. Because of this, I told you that it's a combination of defense techniques. So again, first of all, we need to enable session hijacking. After this, we need to create a bot profile, and under browsers, we need to enable the device ID mode to generate before access. So before accessing our web server, we need to start getting the device ID. And if your bot profile is in transparent mode, you need to enable this one to enable the device ID challenges in transparent mode also. This means that bot profile will not be applied in the blocking mode. So suppose that your bot profile detected that it's a bot trial, the traffic will not be blocked because it's in transparent. Even if it's in transparent mode, I need also to enable device ID to challenge browsers for getting the device ID. After we finish configuring our bot profile, we need to apply this bot defense profile to our virtual server to be applied and to be effective. For any further trial, you will find that the request got blocked using the bot profile and session hijacking protection. Here, you can find that according to browser verification, it's considered a session hijacking, then the request will be blocked. Finally, we have cookie tampering. It's different than the session hijacking. It's changing the cookie itself. So inside cookie components, you have multiple things. So again, it includes all types of data like personal information, name, number, address, and credentials for certain websites, or it can be the settings for specific websites. It's intended to steal valuable information from users. So by changing the cookie to a specific values, this means the attacker is trying to leak the information of the cookie to be entered to another cookie to be supplied to your website, so the attacker can escalate its privileges by doing this. Cookie tampering could be mitigated using ASM cookie added, and don't forget to check the option in the sessions and logins inside learning and blocking settings, as we are going to see during our lab. So our lab will be separated into three main portions. The first portion will be about the CSRF attack and how to detect it, how to mitigate it using attack signatures. The second portion will be about session hijacking, and we are going to see the defense techniques to detect these trials. And finally, we are going to see if we change the cookie before we send the request to our web application, what will be the results. And we are going to see that the request will be blocked, but we need also to make sure that we enable the ASM cookie changing action into the learning and blocking settings. Okay, so first of all, we need to test the CSRF or cross-site request forgery. So I will open this normal client, external Windows client here. Okay, so this is our external remote client on the internet zone trying to access our internal web application using ASM module. Let me go back here to see our web application here. What we need to do is to test CSRF. Before we do so, I will disable the policy for a moment related to ASM module to see that our web application is vulnerable to CSRF attacks. Let me open LTM from here, then virtual servers. Let's open our virtual server here. Then under security policies, let's disable this policy here. Also, I'll disable my bot defense profile that I created before. Let's click update and let's get back to our client testing CSRF attack. Okay, so what is the scenario that we need to test? After you create your own user, you may want to change the password for this user. Suppose that I have a user called guest2 and I need to change the password of this user. Let me log in first. Okay, then I will edit data here. Click on this button to edit your data. Here you can change your password as you see. This is the legitimate source of changing your password because this is the actual source. What if I got this HTML page here and I change it, the URL to point to this URL, means the same page, but from another device, then I run this HTML code and your web application accepted this HTML code. Means it's vulnerable to CSRF attack because simply this HTML page is sent from another source rather than the legitimate source that the user started to change his password. Okay, so I'll try to take this HTML code, copy it, and put it into another browser, for example, within the same device. Maybe I can copy it to another device, like for example Kali Linux, and then we can test from there. But here it's the same idea. If I test it from another browser, it's the same idea of testing from another PC. So I will open Google Chrome and copy it using Google Chrome and run my attack. So again, I will copy this HTML code. I will right-click and click on inspect. Then here I must have a form of input fields. So here's our form, as you see here. I right-click on it, and then I will choose edit as HTML to copy these values. Control-A to copy all of its contents, copy, and then I will paste it into a text document as you see here. Here, this is our form. If I succeeded to run this HTML code from another browser pointing to the same URL, our web application is vulnerable to CSRF attacks. So here, I will change the action to point to this URL. Okay, let me copy it here. Now I'll paste it into action to point to the same URL as you see here, and the method will be post. And here, we can directly, as I told you before, that the attacker will try to change the input fields here to be hidden. Where is input? Here. So he will change the type to be hidden, and also the value will be entered from the attacker. Okay, let me save this as HTML, save as, then I will save it here as HTML, then click on save. Okay, I'll replace it. But let me minimize this. I will open CSRF here using Google Chrome, not Firefox. Let me open this HTML page. See, it exactly looks like the legitimate page of changing the password for the user, and all the data related to the user exists here. If I try to change the password here, for example, I will change it to be another password. I'll increase the letter here and click submit. So here I succeeded to change the password for the user, which is called guest2. This means our web application is vulnerable to CSRF attacks. Okay, so we need a way to secure our web application against these types of attacks. CSRF. ASM module help us defend against these types of attacks through attack signatures. So let's go to our ASM module to see how we can secure against these attacks. Okay, let me apply my policy one more time here. I choose my virtual server, then click on security and policies. Then here it shows application security to be enabled and click on update. So this is our client here. Let me close each browser. Then I will open Firefox. Okay, I think if I open this page directly here using Google Chrome, the request will be blocked. Let me try this. So I will open csrf.html here. Then I'll try to change the password for guest2 to be admin. Anything. Submit. Request is blocked, as you see here. Why request is blocked? Because simply I changed the source that started the process of changing the password, the legitimate user. So this is considered a CSRF attack. So I'm here on F5ASM module. Let me open event logs and requests here. So it's telling you that there is a trial from the attacker illegal cross-origin request, which is considered the cross-site request forgery. So it's blocked by our attack signatures. Okay, so the second portion of this lab, we need to test the session hijacking and see the result of blocking by ASM module through changing the session ID of any legitimate user. So again, what's the idea here? We have a legitimate user using his PC, using a web browser, then he entered his username and password. Among the components of the cookie that will be sent from the client's browser to the web server will be the session ID. If the attacker succeeded to take the session ID by a way or another and entered the session ID into his web browser on a completely different PC, then if the attacker succeeded to do such thing, then our web application is vulnerable to session hijacking. Fortunately, our ASM module is able to detect these trials and block the request of the attacker even if the web application is vulnerable to such attacks. During this portion of the lab, we will try to simulate this trial from the attacker to steal the session ID and log in with the same username and password. So the first thing, as we said before in our slides, is to enable the session hijacking by device ID tracking, as you see here. So you need to check this box here to enable the session hijacking. There is a very important note here to be noticed from your side before you do anything related to session hijacking, which is related to the HTTP profile that you apply on any virtual server. Remember that we said if you need to apply any ASM policy on any virtual server, you need to enable HTTP profile on this virtual server. If you need to enable session hijacking, you need to also enable this XFF, which is related to the device ID polling through JavaScript. So I enable this on the level of HTTP profile. Let's get back to security here to check our application security, policy building, and learning and blocking settings. Also, you need to make sure you enable learn, alarm, and block for ASM cookie hijacking or ASM cookie changing. So here under headers, cookies, you will find that there is an option called modified ASM cookie. You need to make sure that these options are checked related to this violation. Finally, we need to make sure we enable device ID on the level of the bot defense profiles. So I have here a created bot profile. I'll open this profile here. We need to make sure that we enable the device ID on the level of the browsers to be able to get the device ID for each device. So on browsers, I enable the device ID mode before access, so it will verify the device ID before it sends this request to the web server. Whether it's transparent or blocking, you need to, if you use transparent, you need to enable this in the transparent mode if the bot profile is not enabled. Okay, very good. What we need to do now is simply also we need to make sure that our session cookie is enforced, not allowed, because if it's allowed, simply means if anyone tried to change anything in this cookie part session, then there is no violation for this. So we need to make sure that this entity is enforced. So I will open application security and then headers and then cookies list. Okay, here on allowed cookies we have session. We need to enforce this cookie. So I will open the cookie firstly, and then I will not change this one. So I change, and then I will change performance staging because I don't need to bot this cookie in staging one more time. Then I will enforce this cookie to be enforced. So any trial to hijack or edit this cookie will be considered as session hijacking. Let's click on update and let's apply our policy. Okay, then what we will do now, we will try to log in with a legitimate username and password in a legitimate PC, and we will copy the session ID from this legitimate PC to another PC, simulating an attacker. So the attacker has the session ID. He will try to put the session ID into its cookie before sending it to the web application. Then we'll see the result. Okay, so this is our legitimate PC. Here we can navigate between any URL of our web application, logged in using our username and password guest 33. We have here a cookie. If we need to get this cookie, document here on the console of inspect, we can type document.cookie to get cookie here. Okay, so we have here the cookie. Among the components of this large cookie, we will find that there's a part called session here, and all the other stuff is related to ASM increasing mechanisms. So I will copy this session ID here, and then I will put it into another PC with another browser and see if I can log in using this username and password or not. So I copied this cookie session ID here. This is another PC with a completely different browsers and completely different device ID. Keep in mind, what is the reason for blocking the request if it's blocked here? The device ID. So ASM got the device ID of the previous device, which is the legitimate one, and this is the attacker. It has also a device ID, so I can differentiate between them. So the attacker request will be blocked according to this feature. So here I will open our web application. So it opens successfully. I didn't log in with any username and password. If I succeeded to put the session ID again, I can log in with this username and password and do whatever I want. I have here an extension called Cookie Manager. This application can enable me from changing the component of the cookie that I will send to the web application. So I will open this application and I will open it for this current page. So here I can read about all the cookie components for this session. Among these components, we have session here. So if I tried to change this cookie ID by another value, so if the web application is vulnerable to such attacks, I can able to log in with the same username and password related to this session ID. Let me click on edit here to edit this value. I will put the value that I got from the legitimate user here. Then I will click save. Okay. If I try to initiate a connection to the web application one more time by applying the policy, the security policy, I shall be blocked. Let me try to do so. So if I click on set an item, the request is blocked, as you see here. And the reason for blocking must be session hijacking, as we're going to see. Here I am on the ASM module. Let's go to event logs and application and requests. This is the first request that was blocked. What's the reason for this? It's session hijacking. Okay. Also, as you see here, there is a device ID. For all the other labs that we were trying to do, there wasn't any device ID shown here for any request because we didn't enable this on the level of the pod profile. And keep in mind, once enabling the bot defense profile, we need to apply it on the level of the virtual server, as we said before in the slides. Here on the giant labs, we have here on the security and policies a bot defense profile called test, as you see here. And also the logging profile. If you want to see all the requests related to the bot defense profile, you need to enable this on the logging profile. How can I enable this? If I open security one more time and then event logs and logging profiles, you will find that I have created a new login profile called our profile. And among the options of this profile, I have enabled also bot defense to see all the requests related to bot defense. Okay, if you want to see event logs related to bot defense, we will open it through event logs and then bot requests. Here you can see any logs related to bot defense and what's happening here. And again, session tracking has nothing to do with the bot profile. It's just only enabling the device ID through the mechanism of bot profile defense. Once session hijacking is aware of device ID, it can work and it can defend against session hijacking attack. Okay, finally we need to see that if we try to change the cookie itself on the same browser or the same device, changing the cookie without any intervention from any other attacker or any try from another PC should be blocked also. So cookie mustn't be changed, because simply we can change the components of the cookie related to a specific critical values. Okay, so I'm here back on my browser. I changed the cookie, so I will restore this cookie one more time. Then let me get back to our web application, try to refresh my page to be able to see my page, because I refreshed my or restored my cookie again, or it was the session ID. What if I try to change any other component of this cookie, not just the session ID? I'm on the same browser here, okay? So for example, I will go to this part here and then I will delete one letter, for example, or two letters or whatever. Let's delete those values and click save. Let's try to initiate the traffic again to our web application. See, it is blocked. Why it's blocked? Because I have changed something related to the cookie. And we should also see some event logs related to this action from the client. Here, if we open event logs and then applications and then requests, we'll find that there is a violation related to changing the cookie or ASM modified cookie. This is the reason for blocking, as we are going to see right now. So if you open this page here, you'll find modified domain cookie. So modified domain cookie simply means you changed something related to the cookie, and this will be considered also a session hijacking. It's depending on the same idea.